It looks like we are live. So welcome everyone to SQL Friday number 79. And today we have my Swedish, I was going to say colleague, but well, you know what I mean. Erland Sommarskog anyway. Long-term MVP. Still not longer than Tibor, but Erland is one of the people who has been an MVP for the longest time in the world, I would guess. So it's an honor to have you back. You were here previous season, so it's very nice to see you again, Erland.
Yeah.
I will let you do a proper introduction of yourself and the session, but you're going to talk about cursors. That's going to be interesting.
All right. Yes. So welcome to this session entitled "Don't Use Cursors" and subtitle, "Well, you maybe should use a cursor after all." So yes, this is a presentation about cursors, loops, why you shouldn't use them, and when you sometimes actually need to do loops, how you actually should write them. So yes, let's see. Yeah. So yes, my name is Erland Sommarskog, and I live in Stockholm. And yes, as Magnus said, I've been MVP for many years now. Very happy for that because it's a really great thing for me. Very grateful to Microsoft for rewarding me. My email address is SQL.Sommarskog.se. So if you have any questions related to the session or something else about SQL, feel free to drop me a line. And I also have a website, Sommarskog.se, where you find a small collection of larger articles that goes in depth in a couple of topics. However, this presentation is not one of these related to any of these articles, but I will drop a few links to a few items on my website in this presentation. One thing you'll find on my website is the slides and scripts for this presentation. Sommarskog.se/present, and right now it's on the top where you find the slides and scripts for all my sessions. So this is my agenda. I would start to talk about the scenario we're going to work with for the better part of the presentations, the discount at Northfield Traders. Then I will cover, well, why loops are slow, what we should use instead of loop, that is set-based statements, why they're generally faster. But the last thing I would talk about is actually we sometimes need to do loops and how we should write them. So Northfield Traders is an inflated version of an old demo database from Microsoft called Northwind. So it's a little stronger, so it's a Gale that is about 1 million orders. And this particular edition of Northgale, there is a discount system. So you can set a discount given for a specific customer. This customer, we like this guy really a lot. So he gets 10% off. But we may also say that, well, all customers in Berlin, we like Berlin. Berlin is a cool city, so we give them 5% off. So that's the next thing we look at. And then we can also set a discount on country level. And sometimes we might have a general discount for everyone because we are doing a big sale. So this week is 5% off for everyone. But these discounts don't add up. And actually, we're going to take the first number we find. So we may actually decide that, yeah, okay, it's 5% off for everyone this week, but Norway, they got all this, or they say they can always pay the full price. So we're going to set 0 for Norway. That's the way it works. Now, they had a problem at Northfield Traders because, well, the board recently reviewed the discount structure and shuffled things around a little bit and changed things. But they forgot to inform the IT department. So that now they got lots of orders with incorrect discounts. Now they do have a DBA at Northgale. So he wrote a function to return the orders that may be affected. But guess what? He went on vacation, a multi-day hike, no mobile coverage. He can't be reached. Left at Northfield Traders is Joe, a .NET programmer who knows just about enough TSQL to be dangerous, and he's going to do the rest of the work. The last thing the DBA said to Joe before he left was, "Don't use cursors. They are slow." So let's have a look at how Joe is tackling this problem then. So here, first thing I'm going to do, we're going to move to the Northfield database, and we're going to take a look at this discounts table so we know how it looks like. There is an identity column which we're really not going to use. There is a customer ID, there is a city, and there is a country, and all of them are nullable. And there is a constraint saying that at most one of them can be not null. And then there's also the discount, and there's also a unique constraint on these three. So each combination of these can only appear once, and all being null is that catch-all alternative. And let's have a look how big this table is. It's not a very big table. It's only 1,000 rows, a little more than that. And this function, orders to modify, that's the function that the DBA wrote. And let's see, it returns a little more than 30,000 orders. So before I go on, I'm going to actually, no, I'm going to also drop these indexes because if they exist, I don't want them right now. Then I'm going to start this script while I'm talking about it. On the why I'm starting it now, you're going to see. So the first thing is I'm calling this set up discounts. This procedure emulates the board meeting and just moves the discount around to some random distribution. There are a couple of variables so I can monitor Joe's solution, which starts out here. And as you can see, he's got quite a few variables. Then he's got a temp table, hash temp orders, with all the orders he's going to work at. Joe thinks that, oh, the orders table is big. That's 1 million orders. I don't want to go and read this for every order. So I'm going to fill it up with all the information I need once. Good thinking, Joe. Anyway, so he does this with this query. So he's taking this function, which is completely off limits to him because the DBA wrote it. And he gets the order, he gets the customer ID, the freight, because he has to include the freight to compute the total amount and the current discount. Then it starts, it says start a loop, but he's not using a cursor. There's no cursor. He's writing a loop. But anyway, so he initializes order ID to 0. Then he goes and picks up the next order ID, which is big, the smallest order ID that's bigger than the current one. And if he gets back null, well, then he has gone through all orders. Then he reads for temp orders. He gets the customer ID, the freight, and the old discount. And then he goes and reads for the customer, he gets the country and the city, and then he goes to determine the discount. So he first checks, is there anything for the customer? In that case, yeah, we got the new discount here. If not, well, let's try on the city. Well, let's try this one here. And then we try the country. And finally, we're going to try with all or null. And if that didn't work out, well, we don't have any discount at all. And then he checks, very smart, he checks that, did the discount actually change? And if it did, well, then he goes and computes the total amount for all the products on the order and computes the total order amount, which is, well, he applies the discount to the order and then adds the freight, which is not in, which the discount does not cover. And then finally he goes and update that row. And then I added some monitoring to see how his solution progresses. So you can see here that for every 1,000 rows, I'm going to print out a message. It's raise error, but it's level 0. The reason I use raise error, I go with no weight. I want to see as the script is running. I don't want any output, buffered output. Let's see now how far it's been working. And it's gone a little more than about halfway. So it's a tad slow. Let's see if we can find out what. See, it's bit 55. Let's see if we can find out where the bottleneck might be. So I got this to procedure here that I'm going to talk about more later. SQL trace and oops. So okay. It's order. No, order. Sorry, not order ID. Okay, so what it does now is going to set up a trace, which is filtered for SPID 55, which is the SPID for this window. And it's going to run for 10 seconds by default. And then it's going to, aggregate. So for example, these statements here, they were executed 1,257 times. And so I can see the total amount of time they took. I can see the total amount of time, the CPU, the reads, etc. And I can also see the weights. Now, and particularly here, I can see the factor. So in total, these took up 87% of the execution. Let's see what are the slow statements. And you can see these are the access to the temp table. So let's see if we can understand why are these reads so slow. Well, so here's a temp table, but you can see there's no index on it. There's 30,000 rows in that temp table. And, 30,000 rows, that's not a lot for SQL Server. It has to scan that table because there is no index. But, SQL Server can scan that table as quick as you can snap your fingers. However, now, snap your fingers 60,000 times because it has to do that. There's 2 scans in each iteration. Now, not only are your fingers going to hurt, but it's still going to take quite some time. And that is exactly what is happening here. But we can speed this up very, very quick. Simply, so let's see. We have the total now of, well, that's a little more than 4 minutes. But we can speed this up by adding just 2 words. We can simply define a primary key. And this is a good piece of advice. Generally, when you work with temp tables, we often think, I don't need any keys here, but it's just a temp table. But it's a very good practice to set up primary keys on your temp tables and the real primary keys that you actually assume to be unique, no identity column that you slap on. Because one thing is that can help you to make sure that your assumption about uniqueness is correct, and it can also accidentally make your code run faster. So anyway, I'm going to start this, and yep, we can see it's absolutely running fast now, but maybe there are still more bottlenecks. So let's try this again, run SQL trace, and see if something more stands out that we could fix. Let's see what happens. So it runs for 10 seconds, and then it aggregates the information. And that also takes a couple of seconds. But you'll soon see something here, I think. Yeah. Oh, yeah, we have two statements here that takes up in total, almost 80%. So let's see what they are. And if we can make something to make them go faster. Oops, that was the wrong, sorry, I pressed the wrong button. That was the right one. Okay, so these are the reads from the discounts table on city and country. So let's see, it has actually completed. Well, it's now down to 30 seconds. And previously it was, what was it, 260 seconds. So this is an improvement with, well, let's see if I get this right. Factor of almost 9, isn't it? We're adding only 2 words. That's not bad. That's not bad. Anyway, so let's look at this discounts table again. Well, so we have an index on customer, or an index with customer ID as the leading key. So when we are reading for customer, or we are reading for the catch all, the discount for everyone, we can use this index, but not for city and country. We have to scan that table. And it's a very small table, only 1,000 rows, but still it's being done almost 30,000, well, 60,000 times, almost. So it still takes quite some time. So we could try to add some indexes. So I'm going to do that. I'm actually going to add 3 indexes where for each of them, I'm going to have an index on customer ID, city and country, and include a discount. So they're going to be super quick in covering. The last thing about making them covering is probably over the top. Anyway, we're going to do that. And let's see now how it runs. You can see absolutely runs faster now. It certainly does. We're actually not going to try SQL trace again. We're just going to see how long. It took 7 seconds. So again, we gained a little more than a factor of 3 to do this. However, there's still one more thing we can do to make this run faster. And I'm going to open a second script to show this. It's actually almost the same as the previous one, but there is a primary key here. But here it says begin transaction. So it starts a transaction. And then when I've done 1,000 rows, it does commit transaction, it starts a new transaction and makes a commit at the end. Now you may think, so why would that help? Well, we'll see if it helps or not. I think it does. It really is going really fast now. We're down to 3 seconds. That's not bad. We started at 260 seconds. And why is this faster? Well, we're going to come back to that when we go to the slides now. So first of all, when you do, if you do this kind of loop, which is often known as a poor man's cursor, make sure that your iteration column is indexed. You may think, yeah, of course, that's obvious. Do you really spend time on talking about this? Yes, because you wouldn't believe how many times I've caught colleagues red-handed of doing exactly this. They've written a loop and exactly the slowest thing in the whole thing is iterating and getting the next row of the table. Yeah, so this is quite important. And generally in a loop, you want to seek, if you're actually going to do a loop, you want seeks to reduce overhead as much as possible, because even small scans, they are expensive when you do them again and again and again and again. So that's, you want to avoid this. Now, this SQL trace that I show you, it's nothing that I have written myself. It's written by a guy from the UK. His name is Lee Tudor. However, I'm very proud to host it on my website. So it's a free download. And so one thing you saw here, you gave it a SPID to monitor another session. You can also, instead of giving it a SPID, you can give it an SQL batch. So, and then in that case, it will set up the trace for your own, filter it for your own process, and then monitor. And then do this aggregation. It's a really good tool for finding bottlenecks and loops, but it's also good for other debugging stuff. And there's quite a few parameters. One is you can actually collect actual execution plans. So let's say you're running a procedure that runs 200 statements, and you want to see the plan of one of them. Try to do that in Management Studio. It's just going to break down with all the grids. With SQL Trace, you can run that. Okay, here's the statement, and then you can go and look, get the plan. But be very careful of doing that in production, because even if it's filtered for your own speed, it will affect all processes. Now, so what was the thing with this transaction? So when there was no transaction, every update was its own transaction. And when a transaction commits, SQL Server must wait for the transaction log to be hardened. It must wait for actually to be sure that something has been written to disk. So the data pages does not have to be updated, but if the transaction log has and the server crashes, the transaction will be rolled forward. But it has to wait. But when you're inside a transaction, it doesn't have to wait, because, well, if the transaction crashes, the server crashes, well, the transaction will be rolled back anyway. And therefore, SQL Server could proceed just more quickly, and that's why it was faster. Now, as you notice, I mitigate this by adding a transaction, and then I commit it after every 1,000 rows. And you may think, what's the point with that? Well, in this case, it doesn't really matter. But if you run this on a really big thing, and particularly if it's more complicated than just a single update. Let's say that for you're calling us to procedure, that's quite a few things. You may actually see the execution time to start to grow when you do this in a loop. I remember a case when I worked together with a colleague, and he had written us the procedure, and he had a loop which was perfectly okay for the situation, but it was very slow. And I said, but wait a minute, why do you have a transaction? He removed it, and boom, now it ran a whole lot faster. So that's why you should be careful. However, though, ultimately, I think someone is requesting control. I think we're going to deny that. Sorry. Assuming that someone just haven't clicked the button by mistake. So ultimately, though, you have to think that the business constraints will define the transaction scope. So Joe might be told this, that if we have some problem with some of the orders and we can't update them for some reason, we want a consistent view of this mess. Please don't do anything at all. Well, if that is what he's being told, he has to use a single transaction. But he might also be told, that could be some orders that you can't update for some reason. In that case, please don't update the rest. And in that case, well, he actually has to have one transaction for every order, so you don't lose some of them. Now, let's talk about the solution that Joe should have written in the first place. He should, of course, have used set-based logic. So here, to keep in parity with Joe's solution, I still got a temp table, but it's only the order ID this time. And there is a primary key. And I fill it up with the table valued functions. I got these orders, and then I got a single update statement for the operation. And it's quite big, so I'm going to start from the bottom here. You can see and exist from temp orders. So I'm only going to work with the orders that are in the temp orders table. And then I got the orders table. I joined that to the customers table. Then I got this derived table. What it does logically is to compute the sum of all orders in the database, all 1 million orders. But I'm then joining that derived table to the orders table. And SQL Server here is smart. The optimizer is smart. It realizes, oh, I only need to compute the sum for the actual orders in the temp tables. It's going to recast the computation order. And then finally, I got this outer apply here, which is the most complex thing. Now, you may not have seen the apply operator before, but it's really kind of a join. The difference is that in the join here, I got a subquery, which is completely isolated from the rest of the query. In this subquery here for join, I cannot refer to C or O. If I want to, for some reason, join to customers or orders here, I will need to do that inside that query. But with apply, that is exactly what I'm going to do. And there's cross apply and there's outer apply. And I want outer apply here because if I don't get any data back at all, I still want to keep the row from the keep that order. So, and what I'm going to do here, I'm going to get from the discounts table, and I'm going to get all the rows from the discounts table that could affect this order. So those are total 4 possible. That is a match of customer ID, a match of city, a match of country, or all 4 being null. Then I use the top 1 and get the row I want. So I have an order by customer ID, city, and country, all descending, because if there is you may remember if there is a null value when you sort, null sorts first. But in this case, I want the non-null value. So that's why you do this. So and then finally, yes, I got this filter here, the discount change. And in that case, I go and saving the discount and setting the total amount in the same way as before, applying the discount on the product sum and adding the freight. Okay, so let's now run this and see if this might be faster than we had before. It's always exciting. Yes, it was. Not a whole lot. We didn't slash with a factor of 3 this time. It was fairly modest change, but it was still faster. Now, you might be saying to yourself, okay, that was good. It was kind of nice, but you know, that apply, that made my head hurt. Please, can we do this in a simpler way? Yeah, well, we don't have to write it exactly like this. So here is a more simple-minded solution, you can say. We're going to drop that temp table. So I've done that. And here, again, I got a hash temp orders table, this time with both order ID and customer ID. And then also got a hash customers table with the data I need for the customer, that is the city, the country, and the discount. So I fill up the temp orders table with the orders. Then I fill the customers table with the customers on this that are in this temp table. Then I go and update this table, first setting the discount, first by trying to grab it on customer ID. Well, then I try on city for those I haven't filled it up already. Then I try country where I haven't filled it up already. And then finally, I take this catch-all alternative. So now I got that. And then again, I got my update statement. It's smaller than before. I still got this with exists clause to get all the orders in temp orders table. And I got this derived table, but I don't have the out reply. Instead, I got the discount from the customers table. So it was a couple of more statements, but maybe it runs quite okay. Maybe, well, let's see. Let's try it. Let's see how it works out. Oh, it was actually quite a bit faster than the previous solution, although it was more steps. What the reason is faster, I believe this is because these OR stuff here in the out reply is making a hard time for the optimizer. But we're going to do an interesting thing here. We're going to actually drop those indexes on the discounts table. And I'm going to remove all these primary keys in the temp tables in opposition to what I said previously. We should always have those, but just for the test, we're going to do that. And let's see how that affects the outcome. You might remember when we did this with Joe's Loop, originally it was really slow. But look, it was, well, it didn't matter. We got the same result. Interesting, isn't it? Well, let's go back to the slides and talk about this a little more. So first of all, these solutions are faster. Yes, compared to the gains where we did when we speed up the loop, it was not dramatic. Still, the second solution was, well, about half the time, or a little, well, almost half the time of the, I think it was more than half, well, about half the time of the fastest loop. And this particular case, it turned out we didn't actually need those indexes on the temp table and on the discounts table. Now, yeah, let's see, we're going to make it moving ahead of myself here. Now, that doesn't mean that in generally when we work with set-based statements, we don't need indexes. Often we do need, but when you work with loops, they get even more critical because you can avoid these scans. To avoid these scans here, for various reasons, they were not issued because SQL Server did help with them internally in a faster way. And that update statement, well, that's since it works in all rows at the same time, we get that reduced transaction overhead for free. We don't have to bother about that. But of course, but then let's say if the situation is that we actually don't want to fail on a single bad row. Okay, yeah, we're going to come back to that later on. And as you saw, it doesn't have to be one big monolithic statement. It may be easier sometimes and better and faster to bring it up to use intermediate temp tables for various reasons. If you write a really complex queries, often it's faster to put in a temp table somewhere because then it helps the optimizer to make a better plan for the rest of it. Of course, all provided that you do it in the right way. But the important thing is this, that even if you're putting down the data, sometimes you're still getting everything with you at once. You work with all data at once. That's the important thing. So instead of just taking, going one here, going forth and back. We're going to talk more about that later, how that affects performance. Now, make some general observations here. Now, this example was not something very special. No. This is can be very much generalized. For the very most problems you will encounter, a set-based solution will be faster than no matter how well you write the loop. And the reason for this is, well, SQL, right now is a declarative language. You say, I want this result, and you can figure out how to compute it. That's the promise of the optimizer. But when you write the loop, it's more like an imperative language. I want this result, and this is how you're going to compute it, because you constrain the optimizer. So Yeah, if you think that you're smarter than optimizer, write your loop, but be my guest. And still, that's a computer. It's going to work, make that word work to optimize it faster than you're going to do. So now also one thing I like is that code gets more concise. A loop can easily get 4 pages long or even worse. So you have to go up, down like this to read it. Whereas this update statement, well, with a slightly bigger screen, I could fit it entirely so I can see all at once. And I found through the years that makes things easier when I see all it in front of me. Yeah, this is what it's doing. Also, loops are prone to errors. I mean, it's common in any language you work with. 2 very common errors with loops is that you fail to initiate the loop variables on each iteration. So you proceed, but you have a loop. You have a variable which retains the value from the previous iteration, and then you get wrong results. Yes, been there, done that. You're not alone. And also, you might have some condition so you terminate the loop a little too early or a little too late. Yeah, that's also errors we have done in our life. Now you might say, okay, that's great. I understand the theory, but I'll now set-based code up. It's outside my comfort zone. I don't want to go there. Okay, I got some professional advice for you. You need to extend your comfort zone to write these set-based statements. And if that is absolutely completely unnegotiable to do that, well, please stay away from the database, because we don't write code in a database like Joe did. Now, you might be thinking, this set-based, is this some kind of magic? There's no magic in computers. Computers are amongst the most unmagic things I know. No. Set-based, it's actually a logical concept, meaning all or nothing. That update statement is going to update 30,000 rows, or it's not going to update anything at all. That's the whole idea. We're going to work with all data at once, but particularly also everything's going to be updated or nothing at all. But there is no, of course, I mean, there's no computer that can update 30,000 values in one bank like this. Well, if you have 128 cores, maybe 128 values at the time can be updated, but that's about it. No, if you would open the door, look inside the code SQL Server, you would find loops. They got loops in there. Oh, you think, but I like that. I prefer to write the loop myself, so I'm in control. No. That's a very wrong conclusion, because it matters a whole lot where the loop is performed. And now well, this animation is really poor, and had I been live in front of the audience, I should have tried to illustrate it by doing this myself. But so anyway, this here, we have a room or a building. Let's see, where is the mouse? I'm trying to find where I have I have another screen as well. That's why.
I see your mouse pointer moving around in the picture. So
okay,
you're on the right screen.
Okay, then it's okay. So it might. Yeah, I'm also running this on a VM, so it could be on the other machine. Yeah, thank you. So sorry about that. Anyway, so this is a room or a house. Anyway, there is a door, and this inside there is a table or a box, something like that. And there is an arrow. And we have a funny exercise. We're going to walk around that box and touch that arrow 100 times. Now, which is the fastest way to do that? Well, of course, we can make a close loop around the box like this, touch like this, and touch it. And we might get a little dizzy, but we can do that. But we don't have to do that. We can say, I'm going to touch the arrow, walk out to the walls of the room, walk like this, walk along the room, and coming back, going in, and touch the arrow. Well, we can do that. Or we can take it one step further. I go to the door. Yeah, it's a heavy door. Open it, closing it, walking around the block, coming back, open the door again. Yeah, touch the arrow. Yeah, we can do that. Now, which is the fastest way to do that? Well, okay, so the closed loop around the box, we can say this is the batch mode they introduced in SQL 2012, with column store now is available for all sorts of queries because they optimized some things inside the engine. Well, the row walking along the walls inside the room, that's the row mode. They're still avoiding the door, but when you walk outside the door, that's when you run the loop yourself, because you are going to add all that overhead. Because that is all. It's all this overhead when you open that door. because you might repeat all sorts of things when you do that. Well, these accidental small scans I talked about, harden the transaction log for updates, and other things that can have high startup costs. Well, you might be accessing linked servers, a recompilation, triggers, all sorts of stuff. But with the set-based statements, you're only going to open that door once. And to drive this point, I'm going to do a different kind of example. So the task now is to populate an Excel sheet with some data in the database with a PowerShell script. So how will we do that? We're going to look at two solutions, a slow version and a fast version. And this is the slow version. So first I'm setting up some namespaces. I'm creating an Excel object, a book in that Excel, and a sheet within that book. And I got my connection string, which if you try this on your own, you will have to change the server name probably. And then I'm going to run my query. I'm going to get 1,000 rows in that customers table. I'm going to put this, get this data into a data table. And now I'm going to loop through that data table to populate the Excel thing. And I start a stopwatch. And I'm going to loop over all the rows in the data table. And for each row, I'm going to loop over all the columns. And I'm going to write them to one cell in the Excel book. And the last thing I'm going to do after having stopped the whole thing, I'm going to do some cleanup and also going to make the Excel file visible. So let's see, this might take some time. I could get some water in the meanwhile. It took 6 seconds. Well, let's see. We can try the fast version instead. I'm going to get rid of, oh, oops. That's the one. So all the way down here, it's the same thing as before. But now I'm creating here a .NET array. And when I'm doing the loop over the data table, rather than writing to Excel, I write to this .NET array. And then at the end, I'm going to feed this .NET array into full range at one time. And you might be thinking here that, well, that just adding one more loop, that's some overhead, but that's kind of not be smart, can it? Well, let's try it. And it was 0.33 seconds. So it was a factor of 12 at least faster. And why was it so much? And yes, by the way, here's, you can see, I wrote the data to Excel. Get rid of these. So why was this so much faster then? Well, that door, because with the first one, when we did wrote to one cell at once, for each value, I open the door to Excel, and that door goes through com. That's a really heavy door. The hinges are really rusty and they need lots of oil. Give the value to Excel, quickly throw up the value into the right path. I went back again, picked my next value, through that door, and gave it to Excel. The fast version, what I did was that I took my data and reshuffled it and formatted it in a way that Excel can understand, walked that through that door once, and then Excel extremely quickly threw the values around into the Excel book. So that was the key. The loop avoided the transition. That boundary. Now here's another thing. So we have data in the client, and we need to write that in the database. Let's say it's in a grid. So, well, you might think, okay, I need to loop over that grid and write one row at a time. Well, first of all, you will have to wait for hardening the transactional, unless you have a transaction already. So you avoid that thing. But there is also one other thing. There is the network. So now it's not a matter of walking through one door. You're going to open one door, walk through a corridor, and then open the next door to the computer. And that shape of that corridor, well, that can be quite different. It could be very low bandwidth and you have to walk sideways through the data. Or it can be really, really wide. Yes, 10 gigabytes per second or even faster. But no matter how wide, no matter the bandwidth, there is always a sign in that corridor saying speed limit 3 times 10 to the power of 8. The speed of light. That is as fast as you can travel. And if you have the database in the cloud, oh yeah, it's going to get some quite big effect. There is a long distance between the client and the database. So yeah, if you have 20 rows you're going to do that, you might get away with it. 200, or maybe 2,000. No. So you really so what should you do then? Well, of course, send all data at once, just make one walk through that corridor with all the data. And there's a couple of ways to do this. So one way, my favorite way, is to use table value parameters. And there's actually an article on my website to discuss how you can do this in .NET. You can also use the SQL bulk up class in .NET. That might be even faster. Maybe the interface as such is a little rougher, but you can do that. But you might be in an environment which does not support them. It doesn't matter because you can always pack the data in XML or JSON, send that to the database, and then shred it in this just procedure. And it's always going to be faster. So let's have a look at this in practice. So here, we got a script here that's going to do exactly this. So first, I'm going to connect to my local instance. It's going to get 200 rows from the customers table. I'm going to put these in the data table. Then I'm going to connect to an Azure instance that I have in the cloud. I think it's in Western Europe, so I would guess it's in type Dublin or something like that. And I get my connection string, which is not included in the download because, well, you might guess why. And the first thing I'm going to do is just simply going to truncate the target table so we can fill in the data again. And then I start my stopwatch. So here I'm going to start the transaction, so I don't have to wait for the transaction log to be hardened. And then I got my insert statements here, parameterized all the parameters. I define the parameters. I do the loop over the table, fill in the values, and then I run it and I commit the transaction. And let's now see how far this runs, or how fast or slow it runs. And I can get some water and more in the meanwhile.
And I can comment. I love that you're writing .NET code in PowerShell. It's brilliant.
Yeah.
It just adds an extra overhead to it, I mean.
Yeah, it might be. I did it in PowerShell because, well, it was easy for people to use. You don't have to do the compilation since it's a fairly quick thing. And I'm not deleting the Excel. So that's more for the simplification of the demo. Anyway, it was 12 seconds. Now let's try the fast version. Oh, let's see. Oops, sorry. Gonna get rid of that output window. So now we're going down here, and you can see it all. Just say select at input TBL, and then I set that my parameter. It's one single parameter. It has to be structured. And I have to give a type name. So I have to define a table type in my database to do this. And I'm going to set it. And the cool thing here is that I got a data table. I can send the data table as a parameter. I don't need to reshuffle it. So that's really great. And then I just run the query once. So the code is actually quite a bit shorter. And let's see, that was 12 seconds, wasn't it? And yes, there is some overhead from PowerShell from starting the whole thing, but the loop itself, it was, well, a little more than 20 seconds. So it was, what is that? A factor of 50. So much faster it was. And how much faster it would be would all depend on how many rows there would be in that loop. I can tell you, I've actually run this session twice, being on the Pacific West Coast for the same Azure database. For those demos, I think I had 20, 30 rows in the data that I tried to save, and it was still a significant difference. Now, we also need to watch out for the hidden doors. Hidden doors. So what do we mean by that? Well, you see, Joe has been eavesdropping on their session, and he thinks, oh yeah, set-based, I'm going to do that. That's the real thing to do. I've learned something new today. But at the same time, Joe is still a true .NET programmer to his heart, so code reuse is very important for him. So he writes this function called custDiscount, and which is going to make the computation of the discount. So you have seen this code before. We first get the city and the country for the customer, try first on the customer ID, then try on city, etc., etc., etc. And then he got the new update statement here. Now, still got this temp table, still got this drive table. There's no customers table either, but that's 3 calls to that table valued function in all places we need it. So let's see how it runs. It's set based, so it should run in a couple of seconds. It might be running for, yeah, this is a tad slow. And the reason why this is slow is because SQL Server is walking around in the room and going to run that query and it finds, oh, here's the user-defined function. I need to walk into another room to run that function. Walks into that room, runs that function, comes back, walking around, oh, here's the user-defined function. I need to walk into that other room and run that query 90,000 times. Yeah, it was even slower than this loop because there was 90,000 calls to this loop. However, you might remember now that we dropped the indexes on the custom ID, so we can create these again and see that could help because now we are doing all these scans again. So let's see now if this speeds things up. Yeah, but it's still slower though than the fastest loop. So that's quite a bit of penalty for using that user-defined function. So that is the hidden door. When you have a scale of user-defined functions with data access, because they have their own rooms in the SQL Server House. It's a query within the query, which is actually executed separately for every row. Slows things down. And also the optimizer is not doing anything smarter. I mean, for example, for one single row, it could call the UDF once and cache the value. But the optimizer thinks, oh, I don't know. I guess it's cheap. We can probably do this call. It's caching values. That's too much work. I don't want to do that. So that's why you get these 90,000 calls. Now, if you have a scalar function without data access, there's still an overhead for, well, doing the call, but the performance penalty is usually acceptable for you what you want to achieve. Now, I have been lying a little bit here because what I said is perfectly true, 100% true for SQL 2017 and earlier. But they did change things in SQL 2019. Now a scalar user-defined function may inline. So they tried to see if, oh, can we make something smart with this code and try to put it inside the query? So now the optimizer can work with expanded query rather than just having a function call, which is a black box. So we can go back to the window because as it turns out, this function does inline, and I did cheat this by setting the compatibility level to 130 to prevent this. But I'm going to change this to 150, and we can run this again. And now it was the same speed as the fast, or almost the same speed as the query with temp tables. So quite a bit of improvement, although we are actually quite dependent on these indexes. So if I drop these indexes again, as it turns out, I haven't looked how the query panel looked like, but now it runs slower. But yeah, but it's still not disaster. But we're still quite reliant on these indexes. Now, the challenge here is that the rules for when a user-defined function may inline are quite complex. There were some restrictions that were quite clear when SQL 2019 was released, and then they have added more restrictions because they found scenarios. So, oh, wait a minute, inlining did the wrong things here. So you cannot really rely on this unless you really read the documentation carefully. So the general advice is still avoid scalar user-defined functions with data access.
And if I can add something to that, if you run Azure SQL Database, whether it's managed instance or just Azure SQL Database, the function may inline today, but tomorrow it won't, and then the day after it will again, because they have been playing with settings for the inlining back and forth. So
okay, yeah, and also they might have, because they added it, and particularly the early CUs for 2019, they added quite a few restrictions.
There is a question. trace, does it collect info on SQL functions as well?
Oh, yes, I believe the trace causes the functions. We're not going to run it for the slow version to see it does, but I think it captures the statements. It all depending on what trace does. But I seem to believe that, because sometimes you don't really see what's inside the functions, but I believe that trace does. At least you will see the function call that is slow. But I don't think we're going to try to run the slow version, run SQL trace on it to see what happens. Possibly we could do that at the end. So anyway, now continuing on the theme of code reuse. The situation could be this. There might have already been a stored procedure in the system called correct order discount that did exactly the job that Joe had to do. And of course, then Joe might simply have done this. This is also poor man's cursor. It's just a different style. So we keep on looping as long as there is data in the temp order table. Then we get the smallest already, do it for that, run the procedure for that already, and then delete it. This should be selected. If you forget to index the temp table, this is faster than the previous version for the simple reason that this temp table is shrinking. But let's now generalize this. We need to do a process, need to do something on many customers, many orders, many products, or many, well, whatever. And we have this procedure that performs the action on one order, one product, one customer, etc. So now what about this pattern? Is this good or bad to do this? Well, as they say, it depends. So first of all, let me make this clear. code review use is absolutely virtue in TSQL as well. No discussion. However, maybe not as big virtue as in object-oriented languages, because TSQL simply doesn't lend it equally well to code use. So it can get a bit clunky when you want to do it. So let's say this. What you actually have is a procedure that just inserts or updates a single row into a table, and you need to insert or update many. Well, just forget about that procedure and just write a set-based statement. It's not worth the hassle. But you could have something more complex. For example, like this discount correction thing, which is you don't really want that logic in multiple places. So the way you would do this is to write a new procedure with set-based logic. And then you take the existing procedure, rewrite that one to be a wrapper on the old one, so that the processes that calls this one by one can still work. Now, this is not always straightforward to do because, as I said, TSQL doesn't lend itself to do that. We can use a table value parameter in this particular case because it's only input, but often you want data back, and TVPs are unfortunately read-only. But I have an article on my website called How to Share Data Between Procedures that discusses a couple of alternatives using temp tables or permanent tables with split keys, or you can use XML, etc. Now, but the situation could also be this, that you have a procedure that is extremely complex. I remember a case like more than 10 years ago. We had two procedures in the system, both taking like 30, 40 parameters, and both of them are like 1,000, 1,500 lines of code each, and also calling other procedures. And I sat down to make, how can we make this process? How much work would it be to make this process set-based? And I arrived at an estimate of 500 hours. 500 hours, that's almost 3 months of work for a single developer. It didn't happen, at least not as long as I was working with the product, partly because the most complicated case or the most critical case we solved in a different way. But that could be the case. You realize, yes, it would be a great thing to do this, but it's just simply too much work. And I can tell you, I've done this operation for some other not equally big procedures, and it's absolutely not a walk in the park because you have lots of variables, you work with these variables, and then you're going to change that to tables. It's a completely different way of thinking. Even for an experienced programmer, you have to really turn your mindset around to get this, to get it running. So that leads us to this. Yes, sometimes you need to loop. And one reason is this, you need to reuse a complex procedure. It's simply, you cannot simply motivate the investment. It's simply not worth it. Or it could be that you have to call a third-party procedure. That is, you have a third-party system and the vendor has exposed, yeah, if you want to do this, you can call this procedure. And then if you try to, I'm going to skip that procedure, going to rewrite it to do it set-based, the vendor is going to say, oh, wait a minute, now you'll lose all support. You're on your own in the jungle, so don't do that. One example is, well, SQL Server itself with all the system procedures and statements. We have to do them one by one often. Or it could be the case we discussed earlier. You don't want to fail on a single bad row. So that case, well, you'll have to write a loop one way or another. But it could also be that, yes, sometimes it's too difficult for you to write set-based. It's just your head aches. I can't figure out how to do this. And I put for you in parentheses because just by chance, your first name might be Edsig and your last name might be Bengan. And then, yeah, then you might figure it out. But or other mere mortals is going to write a loop. Now, but sometimes, yes, it could be that the loop is faster. Yes, those case happens. Those cases are typically when you realize you can do the whole thing with a single pass over the data, but you simply cannot express that in TSQL. The classic example of this is a running sum up to 2008, before we got the windowed aggregates. We could easily write something that was set-based, but the performance was awful. It was proportional to the square of number of rows. So that leads us, yes, sometimes we need to loop, but these situations are rare. They do occur, but they're very rare. You don't get them every day. You don't get them every week, hardly even every month, maybe twice a year or something like that. Okay, so in that case, how do you loop that? Well, in most cases, ta-da, you write a cursor. Not that the cursors are so much faster as such, but because the risk for hiccups are less than when you wrote your own and use a poor man's cursor. Of course, all again, provided that you set up the cursor the right way. So if you go to Books Online and look at the syntax for declare cursor, you might be, oh wait, that's lots of things here. What? Well, the good news is this is the only thing you need to bother about. Declare, cursor name, cursor, local, static, full select statement. The rest you can ignore. But I'm going to discuss some of these options, what they mean and why you should not use them. So static, first of all, that means that the query is evaluated once. The result is stored in a work table from which the cursor is served. Now you might say, well, if I get 1 million rows, that's quite a bit of an overhead, isn't it? Yes, there is a bit of an overhead. But if you're going to loop over 1 million rows, it's going to be a lot more overhead than the fact that you save them to that table. Now watch out, the default is a dynamic cursor. The query is evaluated on every fetch, as you might guess. That is slow. And not only that, sometimes if you do updates, you might actually have rows coming back in your cursor, getting an infinite loop. I think I've seen that happening, not my own code, but people in forums seem to have run into that. Then there is also fast forward, which books line says, like dynamic, but with optimizations. To be honest, I have not seen a case where fast forward has been really worse than static, not for the whole lot. But I don't like it. I don't even understand what they do. So static is very easy to understand, but so I don't like using things I don't know. And finally, there is key set, which is similar to static, but they only store the keys in the work table. And then when you do the fetch, they will go out to the rows and get the rest of the data. Anyway, don't use any of these options. Static is the only thing that I trust. It's very nice. You work with a snapshot of the data, and this is most often what you want. There's also local and global. So local cursor, that means that the scope of the cursor is this the procedural function trigger where you defined it. So when the procedure exits, the cursor goes away. But the default is global, which means that let's say the procedure, well, right in the cursor loop, it aborts, there's an error, and then you call it again on the same connection. And you don't have any error handling when you do declare cursor, so you don't ignore that error. You continue and you proceed in the loop in the cursor loop where you were, but the transaction you had started has been rolled back, and now you're only going to do half the work. Yes, I've seen this happening. It was nasty. And actually, well, the default setting is actually per database. But the default for that setting is global. And I don't recommend you to use the database setting because then you're going to forget it on the next database. So always use local in your cursor definition. So here's a pattern for writing cursors. You say, well, declare cursor static local or local static, the order doesn't matter. 4, select the number of columns. 4, and order by, because most of the time when you actually have reason to run a cursor, it's probably because you need to process the rows in a certain way. And if you don't have order by, well, SQL Server is free to serve you the rows in any way it sees fit. Then you do open my cur, and this is when the select statement is actually executed and that temp table is populated. And then you start, well, a seemingly infinite loop while 1 equals 1, saying fetch my cur into variables, and the number of variables here must of course match the number of columns in the select statement. Then you use this function at a fetch status. Yeah, it's a kind of weird syntax. It's very old. It used to be called global variable, but now it's a function. Anyway, when this one returns non-zero value, this means that the cursor has been exhausted and you quit the loop. And then the rest, you do the stuff you want to do in your loop. And this could be pages of code. And don't forget to initiate the loop variables. And after the loop, you need to do deallocate on the cursor. There is also close statement, but you don't need that one. But you must do deallocate, even if the cursor is local, because maybe you have nested cursors. Yes, I've written nested cursors. I'm not ashamed of that. And if you don't do deallocate and you come back to the nested cursor again, you will get errors. You need to do this. Here's an alternate way using cursor variables, which is, well, it's had become my favorite in later years. So you have to declare a variable called @myCur, for example, and the data type cursor, a very special data type, not very well known, but it has been in the proto for quite some time. Then you don't use declare, you say set @myCur cursor static. You don't need local here because it's still local to the procedure. 4 and select statements. And then, well, you say the same as before. You do open on the variables, you fetch, do this and check at the fetch status, do the stuff. Now, so what are the advantages here? Well, first of all, if you fat finger on the cursor name, and I do that often because I get really fat fingers, well, then it will be caught at compile time because it's a variable. And very small advantage, but you don't need local, you don't need to allocate, so the code gets a little shorter. So I prefer cursor variables, particularly for this thing, but it makes the code a little shorter. Now, there is one problem here. There are very few people who write cursors this way. Basically, only people that have been my disciples. Most people write it this way, which is an anti-pattern. You should not do this. So what people do, instead of having the while 1 equals 1, they got one fetch before the while, and then they say, okay, while at the fetch state is not 0, do the stuff, and then 4 pages later down to do another fetch. So the problem is here that, oh, wait, I needed one more column in my cursor. So you add it here, and you add it here, you forget this one, and maybe in your test database, you only had one row, so you didn't even notice that this fetch failed. So this is not how you should do it. Now, static cursors are great unless there is a problem, that is, they don't fit the semantics that you have. For example, you might actually want to see changes in the data that occur after you have opened the cursor. I have run into this situation very rarely, but I remember one case. So we had a table that was basically a queue of executions to run of a procedure, and we wanted to pick up new executions that have come in since we have had executed the previous one. Okay, we don't do a static cursor in that case. It can also be that the cursor qualifies many rows by the total condition, but you only need to look at the handful. So let's say 1 million rows, but actually you only have to process 10. But you don't know how many, but you have to, because you have to fulfill the condition. I've also run into this situation very rarely, and that was even a nested cursor. So no, that was not a good idea to have a static cursor. In those cases, you need to do the loop as a roll your own, a poor man's cursor. And of course, you need to make sure that you have indexes to support the loop. That's extremely important. So you don't get being held up exactly by getting to the next row. But never use any of the other cursor types because they're just too confusing and all sorts of things could happen. Let's see, how are we on time? Oh, actually, I think I got a few minutes left. So I'm going to do this demo as well. So here, let's see how we're going to make, I think we have, well, let's see, make sure we have these indexes in place. So this is a loop with a cursor, and this time we're going to skip the temp table. We're just going to put the single join into this cursor. That's also an advantage with using the cursor, by the way. You might remember that Joe first get the next row from the temp table, and then he read the data for that row. He could avoid that by using top one, etc. But anyway, it gets more natural to do this. You put one single select statement to get all the rows, and then, well, do the fetch, and then determine in this count. You've seen this code. This update is the same as before. And down here, we got the same thing for a cursor variable. So just start this and see how it runs. No. Okay. And see how it runs. And this is more or less the same code. Here's cursor static. And let's see here. Oh, this one ran in 5 seconds. And, oh, this one also ran in 5 seconds. So notice we did not have a transaction, so we should compare it to this one. So actually, we did get a bit of a speed up with the cursor, not a lot, but it was slightly faster than running a poor man's cursor. Now, for one more fun thing to do here, let's see what happens if we're going to remove that static. So we got a. Oh, wait a minute. What? Oh, sorry, pressing the wrong button. So, going to remove that static and see how slow this might be. And we're not going to wait forever, but we could wait for, let's say, well, 20, 30 seconds to see if at least the first 1,000 rows come up. But you see, it hasn't produced that yet. Uh, 15, 16, 17, 18, 19, 20, 21, patience timeout. Now, I think the only time I've actually did this, I think it took 4 minutes before I only saw the first 1,000 rows. That is because it has to call this table valued function every time, and that one is not fast. Oh, well, so let's have a summary of what I've been talking about. When people say, don't use cursors, it means write set-based code. It doesn't mean write the loop in a different way. It means exactly that, write set-based code. But that set-based moniker, it really means it is work with all data at once. You carry everything with you at once, rather than going forth and back and taking one piece of data at a time. Avoid repeating scans from source table. Don't write many rows at a time when you can write many. All of these things. Don't repeat stuff when you can do many at once. And avoid crossing boundaries, the doors repeatedly. Remember that Excel example. Remember the access across the network. Then there we got the advantage of set-based, not because of something magic in the engine. It was just something, the Excel, it was completely outside, but it was the same principle. We were crossing these boundaries, and that was why it was so slow. And watch out for these hidden boundaries. So we looked at scalar user-defined functions with data access, a query within the query. On SQL 2019, that You may get away with that because they might inline it, but don't count on it unless you actually want to read the documentation very carefully so you understand when it's going to inline or not. Another thing that you can run into in client code, you might, I got some collection here. I'm going to loop through that and look at that property. That looks innocent enough. Turns out that that property is going to make a database access call for all of them, more or less inefficient. So again, that class maybe should read all data at once and then serve it from some cache or whatever. And because also you need to keep this in mind. When you work with data, you may be working with lots of data, gigabytes, terabytes. You might be thinking, oh, this is a modern computer. It doesn't really matter. It will be fast anyway. No, not when you have terabytes of data. It's still going to be slow if you do it the wrong way. There are situations when the loop is the right thing. And I should hasten to add, in TSQL, very, very rarely from client to server, the only scenario there is that you want some really good error handling. But apart from that, no. But in TSQL, there are situations where loop might come in handy. And when you're looping, the preference is to use a static cursor and avoiding a poor man's cursor. But rather doing that, it's better to roll your own than to use any of the other cursor types. And again, Lead-Tutor's SQL Trace, you can use that to find bottlenecks and loops. Really great tool. And again, you can get it from our website. So that was the end of the loop. My name is Erland Sommarskog, and my email address is sqlserverdatabase.se. You're more than welcome to drop me a line on that if you have any questions. And slides and scripts for this session are available on sommarskog.se/present. And if you download it, and to build a NorthSQL database, you need to run two scripts. You first need to run Northwind, build Northwind, and then you can build NorthSQL from that. So that was all I had to say for today. Do we have any questions in the chat, Magnus?
We don't have questions. We have comments from Gabrielle. Thank you. Mind-blowing presentation. And I think that's the purpose. I think you and I share the same goal. When we come to a client, we don't want to work with super poor performing code. We want to do more fun stuff probably. So if there is any takeaways from this, well, when we come as consultants to your company, we might work with more fun stuff than fixing poorly written loops.
Yeah, then again, the challenge, if you have something which is written by loop or written to do one-by-one processing, it's absolutely quite a bit of an intellectual exercise. I mean, it's always certainly far from always trivial. Let's see. We had this question previously about you have stopped the presentation now?
No.
Sorry,
the recording is still on.
Yeah, I know. I don't know if we want this on the recording, but since someone asks, so let's see. I'm gonna do the slow version again.
If it turns out fine, I'm gonna keep it in. Otherwise, I'll just cut it out. So.
Okay, it's gonna change the compat level to 130. And we're gonna, I think the indexes are, well, let's see. Let's drop the indexes so it gets really slow. And let's make a note here of the, it's 52, this one. Okay. SQL Trace. I've never done this, so this is going to be exciting for me. See if this is going to work out and we can see what the bottlenecks are. One tips about SQL Trace, by the way, there is a parameter to turn off weights, so it doesn't collate weight statistics. Actually, I recommend using that one unless you actually want to look at the weight statistics, because those can take a very long time to collect. Those are collected by extended events, and extended events, as you all know, is a lot slower than Trace when it comes to analyzing the data. Yes, yeah, people tell you that, oh, Trace is such a crap. Well, let's see. I think these are cost discount. Yep, they were covered in inside the function. So, yep, we can see that it. We can see exactly all statements here are from inside that function. So it tells you see the object and the line. It's really great. And we can see that this was the total duration. We can see the CPU, writes, and the weights as well. And of course, since I'm alone in the system, it's all about everything here. So schedule yield. That is just the voluntary yield that they have to do. You know that. They write the code that's way that for every 4 milliseconds approximately they go out and tell the OS kernel that, okay, I can stop now if anyone else wants to run.
Yeah, but I haven't actually used SQL Trace, so I'm gonna dig into that.
Yeah, I love this tool. I don't use it every day, but for loops, for example, or collecting execution plans, or others to procedure have. What is the slow thing? And it's just so it's very well packaged. But as I said, I think this is the parameter. So I think this is the one. Of course, now there's nothing running, so it's not going to capture anything because these weights, particularly if you have lots of weights, it could take a really long time to analyze those. I've run into that. Yeah, of course, this time there was nothing running, so all you saw it was this. Okay.
I have, the optimization you did with just adding a transaction in the beginning. Yeah. I think that's about the only thing you can really throw money on the hardware to. I mean, if you can't change the code, you can't change the code. If it's third party, it's inside a third party application database, then you're kind of stuck with that. If you add a persisted log buffer cache, I think that's gonna be as fast as running in an explicit transaction, because then you don't actually you don't harden the log to disk, you harden it to a ROM, which is persisted.
That's something like a little more advanced. I don't really know about. Maybe you can give a session of that sometime.
I mean, the problem is that they are extremely expensive.
So it's a special memory card. Yeah.
So it's I mean, it does make things for a transaction intensive system where you actually do have transactions which are really small. It speeds up enormously, but I don't have the money for it.
Yeah, that's also a problem with people that just you do many small statements. So, and particularly in these days of the cloud, where you have lots of round trips, that can also makes things go really slow.
I mean, I worked for a while with the casino business, and that's, I mean, you have bets coming in all the time, and they of course have to be their own transaction. You can't bundle them together. So
yeah. That's, as I said, yeah. Of course, there can be business constraints. Of course, you get bets, and okay, we're gonna bash this up in 1,000, and then one of them fails some business. Well, we dropped fails some business rule, and we dropped 999 on the floor. Oh no, yeah.
Too bad. All right, so I see there are no more questions, but there are more comments, and I agree with them all. They all say thank you, great session, and it's a pleasure to have you on here, Erland.
Yeah, see if I can